Do you see my whiteboard or no?
Yes, Professor.
Okay, this topic is about the arithmetic sequence. Arithmetic sequence is special, particular of the sequence, que is super easy to understand. Look, suppose one example. Suppose, remember, sequence is a list of the number, no? Separate by comma, no? 2, 6, suppose, 10, 14, 18. And comma, bam, 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 bam. These three periods indicate that this sequence continues forever to infinity number, but following the same pattern that you see, that you discover in the 1, 2, 3, 4, and 5 element, ¿no? Entonces, bueno, one fantastic way is, you suppose que es arithmetic. What means to be arithmetic? Oh, that the separation between the element is constant. So you subtract 6 minus 2 is 4, 10 minus 6 is again 4, 14 minus 10 subtracting is 4, and you see, wow, it's the same. So it's the same, and this 4 is common D, and D is a common difference. See, this situation is not satisfied. Of course, it's no arithmetic sequence, but we study now arithmetic sequence, okay? And the formula is A sub n. A sub n represents the element in the position arbitrary, M. Is equal A1, that represents the element in the position 1. Okay, by the way, it's this, no? Remember, this is M, F1, F2, F3, F4, F5. Sandra. Okay, Sandra, hello. Plus n minus 1 multiplication by d. In our specific example, a sub m is 2, because a1 is 2, is the first, look at that guy, and d is 4. So now you replace this plus parenthesis n minus 1 multiplication by 4. N no, n dependency, the position, it's the position of the sequence. Leave it like that. No. Use simplification a little bit. This is 2 plus 4m minus 4 is 4m minus 2, no? Because negative 4 and positive 2 together. So the formula to generate any element in this sequence is multiplication by 4m minus 2. Bam! This is my formula. Okay. Let me check it out, see it's good or no. Suppose n equal 1. The formula say 4 times 1, because n is 1 minus 2. 4 times 1 is 4, and 4 minus 2 is 2. Okay, cool. The second is 4 times 2, because n now is 2, minus 2. It's 8 minus 2 is 6. Bam! You understand very well? Yes or no?
Yes, Professor.
It's easy. One more example. Suppose que it's given, this was example 1, easy. Now example 2, I change a little bit, not too much. Suppose example 2 is, for example, A1 is 0. So it's given the first element in this sequence is 0, okay? And the common difference is 1 over 10. So I have two questions. Question number 1, compute A sub n formula, explicit formula. And why not evaluate A in 27, in the position 27. Okay, I copy my formula. My formula says that A sub n is equal to A1 plus parentheses n minus 1d. This is my general formula. My specific for this example is A sub n is 0, because A1 is 0 plus parentheses n minus 1 multiplication by 1 over 10 is a fraction. So the conclusion is n minus 1 over 10. The A sub n is equal, you expect any possibility, fraction, decimal, whole number, of course, every possible. This is the formula. It generates, suppose I want to find one specific, well, you plug it in, you replace n for 1, 2, 3, but in this case, they want 27. So a and 27 is equal to 27 minus 1, 27 minus 1, I did quickly, 27 minus 1 divided by 10. 27 minus 1 is 26. Divided by 10, you can reduce the lowest term because both numbers are even number. 26 divided by 2 is 13. And 10 divided by 2 is 5. And that's the answer. The answer is 13 over 5 is the element located in the position 27 in this sequence. Okay. That's easy, eh? But I want to complicate it a little bit, not too much, not too much. Suppose you find the sum. So the sum of this sequence, arithmetic, obey to the one formula. And the formula is too easy. Let me show you. Summation of the first element, so suppose A1 plus A2 plus A3 plus plus A sub m. Okay, you can, if you want, no, represent like a summation notation. No? This is K1, okay, is the first one, look at that. To M is the last one. This guy, maybe 40, 200, I don't know. A sub K is one formula. The formula is you take the first, you take the last addition, divided by 2, and multiplication by n. This is the formula. This is the formula que guarantee us easy. Compute the sum of the different number that you put together, addition, but they represent the arithmetic sequence. Let's see example. Example 3. Suppose this 6 plus 12 plus 18 plus, when I declare a 3 period, indicate that this contains forever in the same pattern. And the last guy is 480. Compute this summation. So, well, first of all, you say, wow, is the geometric sequence yes or no? Arithmetic sequence yes or no? I don't know. You're subtracting here. It's 12 minus 6 is 6, and 18 minus 12 is 6. Oh, yes, D is 6. And in 1 is, okay, this is important. D do not participate in the formula. However, it's important to classify. It's arithmetic, therefore, that formula is valid. Because you see another sequence we studied today, que es different, entonces es another formula, ¿no? And A1 is 6, and A sub n, in this case, is 480. Cool. But the only thing we don't know M. We have that is 6. We have that 480. We don't have N. Okay. But we found. How you find that? Well, easy. You know the formula que help me to indicate position. A sub n is equal to A1 plus n minus 1 D. Now ahora we're using D, que es 6. Using D, que es 6. So A sub n. Bueno, A sub n, I know who is this. A sub n is the last guy, que es 480. Es equal. A sub 1 is the first one, que es 6. Plus n minus 1, multiplication by 6, que es D. Now we apply algebra, distribute the property maybe, 6x minus 6. Oh, it's easy, it's 6m. Because positive 6 and negative 6 is cancelled, and it stays. Now, so for m, 480 divided by 6 is equal to m, que is 80. Okay, so basically, our summation contains 80 element. Okay, you don't see at the beginning here. You see 3, and this symbolic way indicate continue forever but and stop in 480, but you don't know. See, this is n equal 1, this is n equal 2, this is n equal 3, 4, 5, 6, 7, and this is n equal 80. Now in the formula we have summation, 80 element. Let me use in this new notation, S sub m, is summation, capital S, summation, 80 element, is 6 plus 480 divided by 2 and multiplication by 80. Okay, so it's easy because you're adding this. Well, this is calculator. This is calculator. This is the 480 plus 6 divided by 2 is 243. Multiplication by 80 is, let me copy here down, 19,440. This is just calculator. You're adding, the order of operation is, you add in the top part, 6 plus 4 is 400, 86, no? Divided by 2 is 243. And finally, multiplication by 80. Is this answer. Okay? Let's do another, a little bit different, similar, but a little bit different. A little bit different, similar. Do you follow me, guys? Yes. So the example 1 and 2 is the determine the position, determine the element in the position. This is different. This is addition. When you add in the first element in one arithmetic sequence, how you find the final answer, how you find the sum. Let me try one more example. Example 5, no? 5. Let me see. I know. Let me see. No, 4. 4. Example 4. And example 4, for example, is given this idea. Compute summation, and this summation notation, okay, of from n equal 1 to 27, and the expression inside is negative 4m minus 2. One possibility is manipulate this using the property of the summation notation. Okay, it's possible. We can do. But not now. Not now, because I discovered that this sequence, que es minus 4 and minus 2 is arithmetic. How do you know it's arithmetic? Because it's linear. It's linear. So suppose that the linear equation that you are related is mx plus b, no? Is the connection in between x and y. We have no exponent 2, 3, 4, 5, is exponent 1, is linear. And this is also linear. When this situation happens, when it's linear, it's arithmetic. Because the common difference can represent somehow the slope is negative 4. Entonces now, I know the formula. The formula que professor explained was A1 plus A27, because it's the last one, 127 divided by 2. A multiplication by m, pero n is 27, no? Because n is the last number, 27. It's from 1 to 27. But to find A1 is easy. A1 is evaluate negative 4 times 1 minus 2. This is negative 4 minus 2 is minus 6. Okay, I know that A1 is minus 6. Plus A27 is negative 4 times 27 minus 2. Okay, I put in the calculator, it's negative 110. So actually it's no plus, it's minus. Well, plus and minus together is minus. Minus 110 divided by 2, multiplication by 27. The rest is just calculator. And the answer is negative 1,566. Easy, easy, easy. Okay, what possibility is? Suppose, well, this is a possibility that matches perfectly for the topic we are studying now. However, some people don't remember very well that formula. Suppose you don't remember very well that formula. And you need to manipulate using the property for the summation notation. Okay, let's do it. This is summation for n equal 1 to 27 of the minus 4m minus 2. So the property, one property say when you have a binomial or trinomial, you can break it down like that in two summations. No? One summation is -4, but actually -4. Another summation is -2, no? Plus in between. No? Now this go from 1 to 27, and this go from 1 to 27 again. Okay, this property is super important. It's a property number 2. It's linear. Suppose you have summation for the binomial, trinomial, you separate in 3 and 4. In this case, binomial 2. Well, one more thing. This 4, if possible, it's a constant you factor out outside the summation. And you have a specific formula to compute that. So the formula to compute this is -4, I bring down -24. This is 27 multiplication 27 multiplication by 28 because it's n plus 1 divided by 2. This is the formula to this. I put in my calculator now. No, actually we can simplification these two, and this is -2, no? So it's -2 times 27 times 28 is 1,000 negative, of course. Negative, don't forget the negative. Negative 1,512. Now let's move into the second. The second is different formula because here do not depending of m. It's just a constant, and the constant is the multiplication -2 times 27. This is -2 times 27 is 2 times 27. I'm doing my calculator. 54 -54, and together 54, and together is 54 plus 1,512. The total answer is the same. It's negative 1,566. So either way, this is the beauty of the mathematics. When you're working well and you apply different methods, different formulas, or different criteria, obviously you get the same answer. And you are doing well, no? Of course. Okay, so you understand very well the idea behind the arithmetic sequence? Easy, eh? Now let's move on to the geometric sequence. Geometric sequence. May I erase the board or not yet?
Yes.
Okay. Now geometry. Geometry is a little bit similar. Geometric sequence. Okay. One example to understand geometric sequence. Suppose this. Suppose 4, 16, 64, suppose you want to investigate. Remember, this is the A sub m, and we have m here. Okay? 1, 2, 3. Always the domain independent variable is the natural number. Start 1, 2, 3, 4, 5, 6. I need to discover the formula for the A sub n explicit formula. When you're subtracting, it's 12. But when you're subtracting here, which is 64 minus 16. 64 minus 16. What the hell? Let me clear. 64, that's the big one. Minus 16. It's what the hell happened here? Let's do it by hand. 64 minus 16 is 14, is 8, and it's a 48. It's so big and no. It's so big and no. It's not arithmetic sequence because we have no common difference. Okay, but let's change the operation. No subtraction anymore. No. Division. You divide 16 divided by 4, F4. And you divide 64 divided by 16, F4. So now the thing is common is not the difference, it's the division. And this is called R. It's common ratio. Because the word ratio somehow indicates division. So basically you divide any guys divided by the previous in the position -1, and the answer is always the same. Okay, so we have the formula. The formula is in general for any geometric sequence. A sub n is equal to a sub 1 again, multiplication r n minus 1. This is the general formula for any geometric sequence. However, in our specific example 1 for the geometric, A1, F4, A1, F4, and the common ratio is a coincidence, is 4. Okay, no always happen, but in this case happen. Say R 4. Now the A sub n, this is A sub 1. Sorry, this is A sub 1. Therefore, A sub n would be 4, according to the formula, 4 A sub 1 times 4 again, repetition, and minus 1. You can leave it like that, but much better, in my opinion, is put together. This is exponent 1. And when you put it, 4 to the n power. And makes sense, because 4 to the 1 is 4, 4 to the second is 16, 4 to the third power is 64 also. This is the formula. Cool. Let's see another example, a little bit more tricky, complicated. It's the same formula. Suppose. Do you understand geometry idea? Yes or no? Yes or no? 10, 9, 81 over 10, 729 over 100, comma, that. So in this case, I want to find the formula, A sub m. I want to find A sub 9 in the position 9. Remember, this is a position 1, 2, 3, 4. I need position 9. 5, 6, 7, 8, and 9. Okay, then first of all, I try to prove geometry. To prove geometry is easy, you divide 9 divided by 3. And leave it like that. No. And you divide this divided by this. It's 81 over 10 divided by 9. This is 81 over 10 times reciprocal of this is 1 over 9. Oh yeah, you can simplification. 9 divided by 9, 1. 81 divided by 9, 9, because 81 is 9 times 9, no? This is 9 over 10. You want to make sure, well, okay, let's do in the last division, no? 729 over 100 divided by 81 over 10. And copy 729 over 100 times reciprocal. Reciprocal is 10 over 81. Well, at least the number ending in 0 is cancelled. So 10 divided by 10 is 1, and 100 divided by 10 is 10. And 729 divided by 81, you put in the calculator if you want, is 9. The answer is 9 over 10. So for sure, I investigate okay, the common ratio is 9 over 10, 9 over 10, 9 over 10. And we have, at that moment, okay, the first guy in this sequence is 10. Look. We have, okay, the common ratio is 9 over 10. Therefore, the formula for the a sub n would be that formula. I apply that formula one more time. Is 10, is a1, raised to the 9 over 10, raised to the n minus 1. Okay. You can leave it like that. You can leave it like that. Well, I don't know. Maybe yes or maybe no. Yeah. You can leave it like that. Another possibility is 10 times 9 raised to the n minus 1 exponent. You split this denominator, this exponent in two numbers, and this is 10 n minus 1. Oh, you can simplification that thing. This is 9 raised to the n minus 1. It stays the same, but this is 10 to the n. Because you're subtracting the exponent. No, let me try. 10 to the 1 divided by 10 to the n minus 1. You're subtracting the exponent. It's 10 to the 1 minus n plus 1. So you change the sign of this. Is it cancelled? No, wait. Oh, something is wrong. I did wrong. Okay, this is, let me see. 1 minus, it's 10 to the 2 minus n. Okay, entonces no like that. It's 10 to the 2 minus n. Okay, entonces I don't like this. It's correct, but I prefer continue working with this. Sound not too complicated. Suppose I want to find in the position, what position 9. Well, that's easy. When you have the general formula explicit, you plug in 9. Entonces, a to the 9 is 10, raised to the 9 over 10, raised to the exponent is 9 minus 1 is 8. So it's 10, 9 over 10 to the 8. Entonces, it's 9 to the 8 power divided by 10 to the, let me see, 1 and 8 is 1 minus 8 is 7. It's 7, yeah, because it's 10 to the 8, subtracting the exponent, it's obviously 7. 7 actually. This is reciprocal. It's in the denominator. You can put, if you want, this number in the calculator, and they get a huge number, right? Like a fraction or like a whatever. It's 4304 6721 is 9 to the 8 power divided by, well, this is actually 10,000, yeah, 10 million, sorry. So it's 1 2 3 4 7 0 1 2 3 4 5 6 and 7. Oh, so you don't like this answer, you can express it in decimal, no? It's 4.3046 4671. Okay, something like that. Okay. The complicated part is the number, but the formula is easy, right? However, we have another formula in order to find the sum of the number. So the sum, so sum, the same formula that we studied, but in geometry is different. Is sum. So suppose que we have A1 plus A2 plus A3 plus plus A sub n, and they are geometric, no? Geometric sequence. Okay. Is summation m. In the geometric sequence, the formula is different. It's A1, is the first one. Entonces you have a fraction. And the fraction you have in the top, in the numerator, 1 minus r to the n power. Remember, r is the common ratio, 1 minus r. Something like that. This is the formula to compute the summation of the first number And the sequence gets geometric sequence, no? Okay, let me try. Let me try one example of this. Let me see. What's the best example? In my opinion, is this. It's easier. Look, suppose example number 3, no? Of that part geometry is suppose 1/2 plus 1/4 plus 1/8 plus pa. In general, well, no. Okay, that's it. Or no, stop here. You see, when a professor, I can compute it by hand without formula. Yes. Of course, you can compute it, but I want to illustrate. This is the n equal 1. This is n equal 2. This is n equal 3. This is short summation, but if it's long, we can use that formula. No? Let me try to illustrate this. And this, using short, doing by hand, and doing using the formula. In this case, this guy is A1. The A1 is 1/2. However, the common ratio R is no idea. You divide this divided by this is 1/4 divided by 1/2 is 1/4 times 2/1 is 2/4. Okay, reduce the lowest term is 1/2. Well, it's 1/2 again. Again, it's a coincidence. Whoa. Okay, entonces now, suppose que I apply that formula. Suppose S and 3. Why in 3? Because it's 1 to 3. Because A1 is 1/2. Is this. Now, parentheses, 1 minus 1/2, because R is also 3, it's a coincidence, raised to the cubic power, because the summation contains 3 elements, plus the parentheses, divided by 1 minus 1. Okay, let me try to do my best. Is according to the order of operation, we are doing this operation first. Exponent, no? Or parentheses. It's a 1 minus 1/8, because 2 to the cubic power is 8. 1 to the cubic, you know, 1. And 1 minus 1/2 is 1/2. It's easy. This and this is cancel out, multiplication and division by the same number. And this is 8/8. 1 is 8/8 minus 1/8 is over the 7. This was the answer using this formula. Sound too long? Complicated? Maybe. I don't know, but it's useful. And when you have the summation long, no? Suppose you need to add in the first 100 term of the geometric sequence. So now, wow. By hand is impossible. Not impossible. You spend 2 weeks doing that. However, let me verify this answer. 1/2 plus 1/4 plus 1/8 is easy by hand. Least common denominator obviously is 8. 8 divided by 2 is 4 times 1 is 4. 4/8 and 1/2 is the same fraction. Plus 8 divided by 4 is 2 times 1 is 2. 2/8 is the same fraction. 1/4 plus 1. Thus we have 4 plus 2 is 6 plus 1 is 7/8. Wow, exactly the same answer. And this is expecting, of course, because the mathematics, everything you are doing well, you get the same answer. But I want to complicate your life now. Suppose a long, it's impossible doing by hand. Let me try to find one easy example. That one, it's okay. Example 4. Example 4. Example 4 is given, but not in the traditional way of the separate summation. No, it's given like a summation notation. Okay. I am not totally lie, but I understand. It's a 2/3 raised to the 2. Compute that. I mean, you can expand 1 by 1. 1, 2, 3, 4, and 5. I'm adding. It's a 1 possibility. But no. Let's do it using the new formula, no? So the formula, I want to copy one more time. X5 is equal A1 1 minus Rm and 1 minus. This is my formula. Who is R? Who is A? I don't know. I don't know. To find the first, you suppose K equal 1. Entonces, 2/3 times 2 to the 1 power. Oh, it's 4/3. This is A1. And the first in the summation is 4/3. Who is R? Well, I propose you take the second. So I guess 2/3 times 2 to the second power. So you suppose K2. Because we have 2/3 times 4, no? It's 8/3. And this is A2. And remember the ratio, see, it's common. You divide A2 divided by A1. Common ratio. It's 8/3 divided by 4/3. Because we have A/3 times flip it. Flip it is 3/4, no? Cancel out that part. Okay, and the answer is 2. And the answer is 2. Okay, that's 2. Okay, cool. Now I compute the summation in the 5 first element. Okay, is for there multiplication by 1 minus 2 is R. This is R raised to the 5th power 5 because n is 5. 1 minus 2. Okay. 2 to the 5th power is 32. 32. But actually it's 4/3 time is a 32. It's a 32. Pero 1 minus 32 is negative 31. And 1 minus 2 is negative 1. So the answer is, well, is negative divided by negative positive. Multiplication 4 times 31 is 124 divided by 2. Yes. 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 Guys, do you follow me or no? All right,
Yes.
We have more students. Monique, Leslie, Patrick, Angelina, Sandra, Yailin, Torralba. It's the best student que always get good grade. Walter William, Geraini Izquierdo. You improve a lot of Geraini. Fabiana and Anthony. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 9, yeah, 12, 13. 13. Okay. Okay. The student is coming after the beginning I explained. Are you aware, no? In this video today, I have sent the test number 5 and the final, no? When I have the final, I highly recommend it taking because always improve. Suppose the majority of students are doing well in the test on paper, but in the Alex, you know, you don't. Some students, yes, excellent, but the majority of the students don't dedicate too much time. I understand. I understand that we are living in the complicated country, but you need to understand me. When you're adding, si you don't have the score, you don't pass. Okay, so now you need to make, you know, the last finally is 4 to improve, right? So now the final is and one opportunity to improve. So everything is due Tuesday. It's the next Tuesday, no? Next Tuesday, no. It's next Tuesday. I'm confused. Okay, today is 17. Yeah, next Tuesday. It's 25th. So we have lecture today, 17. We have lecture 19, I suppose, to make a review. We have 24. I don't know if we finish or not. Depending, no? If we finish, not necessarily expect 24 like a lecture, or maybe as a continuation of the review package. And 25th, live day. I receive everything, you submit online the thing, and 26th in the morning, I consolidate your score and my grade. Okay, because I need to present as soon as possible this week. We are talking about next week. No? Next week. Are you clear? I ask again. You clear?
Yes.
Okay.
Yes.
Okay. I don't want delay. Sorry. No, okay, I have problem. No problem. If you have problem, bueno, entonces you repeat again. That was. When you have no problem, entonces you are ready to take. Okay. You see my whiteboard, huh?
Yes, Professor.
Uh-huh. Let me study another thing. Very interesting and very important. Is the geometric series. And this is different. No sequence, it's series. Why series? What is series? Well, a series is one summation. And we have here a to k from k equal 1, but here infinity. Wow. What is that? This is a1 plus a2 plus a3 plus but never finish. No ending. No. Continue forever. This is serious. And you see, one of professors, you adding infinity number, the answer is infinity. Well, yeah, the majority of the scenario, yes, but we have two possibilities. We have the sum is infinity, and when the situation happens, that is called divergent. But sometimes magic, I want to explain now. The answer is a number, and it's convergent. And let me see what depending convergent or divergent. Depending. If the common ratio, the famous common ratio, absolute value, positive or negative, is less than 1, therefore our series converges. Okay, this is the noun, convergent, and this is the verb, converges. And otherwise, you know, if the opposite case, absolute value R is greater than or equal, including equal, 1 is divergent. And the reason is clear, and this when this common ratio is less than 1, you adding pero infinity, but this is small, and not necessarily always case of more convergent. But in this case, yes. Let me try to explain two examples. And why not? The geometric interpretation. This is what we are. Okay, you add infinity number, and the answer is a number. Oh, well, let me try. Suppose. Let me, like example 1 of the series. Suppose you adding 1 plus 1 half plus 1 over 4 over 4 plus 1 over 8. You see how the element is smaller, and so on. The next it would be 1 over 16, 32, 64. This is 64. No, 32, sorry. 32. Okay, this obeyed like exponential. 32, 64. So basically the pattern is, this is 2 to the 0, 2 to the 1, 2 to the 4, to the 4, not to the second. So 2 times 2 is 4, to the third is 8, to the 4, to the 5th, and to the 6th. Entonces es important predict. Es possible predict. This is plus and this is infinity. Bam, bam, bam. It's a little bit easy predict prediction. A1 is over the 1. And the common ratio is 1/2. By the way, is less than 1. Now, this example is converging. Okay. That was the example I selected to illustrate you guys converging. And the A sub n is, according to the formula for the sequence, is A1 Rn minus 1. Is 1 times 1/2 raised to the n minus 1. But the formula is A sub n is 1/2 raised to the n minus 1. And this generates this number, this number, this number, and this. But we are talking about not this. You know, we are talking about the summation. Okay, entonces now, the summation, suppose que I am doing no formulas, you know, intuition. After I promise that I want to apply one formula. Okay, suppose the line. Suppose one line. And this is A1. We have 0 here. We have 1 here. And why not 2 here? 3, 4, 5. I don't know si continue or not. The first, que es 1, is that distance. The second, que es 1/2 plus after 1, is that distance. Here 1.5, no? You adding plus 1/2. It's a 1. This is 1/2, and together is 1.5, 1.5, 1.5, a mixed number. And the third one is 1/4. It's the half of the half. Do you see how the number continues, pero es too small and too small? Después 1/a is too small. Después 1/16, too small, 1/32. And do you see, well, I don't know if you see, que do not overcome 2, yes or no? You suppose que we continue? You suppose que we continue 2.5? No, that part is illegal, no? So now, wow, unbelievable. This summation of the infinity element is 2. But I want to prove. The formula comes from, for this formula that we studied before, A1, 1 minus Rn, divided by 1 minus R. See that formula, you separate it in 2 pieces. The first is A1, 1 minus R. And you split this common denominator, minus A1 Rm divided by 1 minus R. And you suppose I want to compute the summation of the infinity element, that you create que n is infinity. N is infinity, okay, when n is infinity, that part stays the same. It stays the same, so S in infinity. Normally, in the book, never put the infinity here. You put capital S, and everyone understands que it's at infinity. It's A1 over 1 minus R, and that part is going to 0. Why is going to 0? Because the R is less than 1. You know, when you, for example, you have 1/2 and you raise to the third power, it's 1/8. But if you have 1/2 and you raise to the fourth power, it's 1/16. You see how the denominator increasing faster and the fraction is going to 0. Suppose we have 1/2 raised to the 400, so it's a number, super small number, close to 0. This part approaches asymptotically to 0. And this is the formula. The formula is summation of the infinity element is A1 divided by 1 minus R. Wow, it's easy formula. It's easier than when it's no infinity. Okay. But you need to prove first que converge. How do you know? You find the common ratio. Si the actual value common ratio is less than 1, it converges. And converge to what value? That value, that formula. Let's do it. Let's apply that formula in this example. In the example 1. Okay, we are using intuition and you get the answer is 2. Let me verify if it's true or not. S is equal A1, que is 1, divided by 1 minus 1 half. Because the common ratio is 1 half. Entonces es 1 over, this is 2 over 2, minus 1 half. Es obvio que es 1 half, ¿no? 1 over 1 half, and the reciprocal 1 half is 2. Bang! Beautiful. The answer is 2. The answer is 2. Series. This series, guys, is a topic that you come back again in Calculus 2. The student can need to take Calculus 2. One more example of the series. To be converged, we need 2 things. Number 1, to be geometric. All series no geometric. And number 2, the common ratio actual value is less than 1. See, these 2 conditions is given, is satisfied, is converged. Otherwise, diverge. It's very, very weird one series to be converging. The majority of series, no, it diverge. Suppose an example 2. Example 2 is 2 plus 4 over 3 plus 8 over 9 plus 3 period. Remember, 3 period indicate us que contiene 4. Okay. First of all, I want to investigate si geometry or no. Well, you divide this guy divided by this guy. 4 over 3 divided by 2. 4 over 3 times, flip it that, is 1 half. So say simplification a little bit, divided by 2, 1 divided by 2, 2. 2 over 3. Let me double check it with this couple. 8 over 9 divided by 4 over 3. It's 8 over 9 times reciprocal, 3 over 4. Oh, you can simplification. Divided by 4, 1 divided by 4, 2. Divided by 3, 1 divided by 3, 3. It's 2/3 again. Our common ratio, yes, is 2/3. And 2/3 is less than 1. So we prove mathematically that we have one geometric series and the common ratio is less than 1. Therefore, the series is converged. But the challenge is at what value converge? Converge at the value given by the formula. What formula, Professor? A over 1 minus R. A1. Sorry. S is equal A1 over 1 minus R. A1 is 2. This guy is A1. This is A2. This is A3. This is 2 over something. 2 over 1 minus 2/3. This is 2 over 1. Well, actual 1 is 3 over 3. No? 3 over 3. 3 over 3. 3 over 3. 3 over 3 minus 2/3 is 2 over 1/3. 3 minus 2 is 1. Entonces, reciprocal is 2 times 3 over 1 is 6. The answer is 6. O sea, what is the conclusion of this example? The conclusion is our series is geometric, is convergent, because the common ratio is less than 1, is 2/3, and convergent to what value? At the value 6. When you adding infinity element of this series, the final answer is 6. Cool? Cool?
Yeah.
Excellent. I promise. In the review packet, you see more examples, more que cover that part. Okay, let me try to explain the last part. The last part, no. the last before the last part is mathematical induction. Let me try to explain because it's easy. However, the student don't understand very well because it's a little bit confusing the theoretical part. But no, I want to explain clear. Suppose that this idea. So the name of the topic is mathematical induction. Mathematical induction. And the mathematical induction, guy, is a powerful method to prove the formulas. What is the idea behind mathematical induction? I want to put a motivation example. And after I want to explain the theoretical part behind the mathematical induction, and say you, after that you apply the algorithm and that's it. Suppose we have n equal 1. And n equal 1 is, or suppose que you adding. The 1 plus 3 plus 5 is adding the first odd natural number. But no, I skip the even, no, odd. 7, 9, no? And the next. Let's see what happened here. Suppose n equal 1. N equal 1. 1 is 1. 1 is 1. But whatever, I forgot this part. Okay, look. Okay, magically happen. Okay, magically happen. Suppose. Okay, you ending in the last odd number. Okay, not the last. Hypothetically, I put 2n minus 1. Okay, let me see. This is the formula que somehow generate that number. Suppose n equal 1, 2 minus 1 is 1. Boom. And n equal 2, 2 times 2 is 4, minus 1 is 3. Okay. And n equal 3, 3 times 2 is 6, minus 1 is 5. And so this is the expression that generate the odd numbers. So you adding odd numbers, and magically happen that the answer is equal n squared. Sound weird. But let me try to understand this. Okay, suppose n equal 1. So you plug in, n equal 1 in the left-hand side, and in the right-hand side of this hypothetical formula que somehow I want to prove. N equal 1 is obvious what? That one. Equal. In the right hand side, you put 1 square. You replace n for 1. It's obvious que it's true. Because 1 is equal to 1 square. This is true. So work, at least work. For n equal to, well, we have 2 elements, 1 plus 3. In the left hand side. In the right hand side, no, we have 2 square. But 1 plus 3 is 4. And 2 square 4 is also true. Wow, sound logical. Suppose n equal 3. 1 equal 3 is 1 plus 3 plus 5. 1, 2, 3 would be 3 square. So 1 plus 3 is 4 plus 5 is 9, and 3 square is 9. It's also true. Wow. And you believe that this continues forever or in one moment fail? False. This is a challenge. Prove that. And to prove that, we're using the mathematical induction. Do you understand the idea? Oh no?
Yes.
I want to explain the theoretical part behind this. And this is amazing, science fiction. Look, you can do infinity possibility. No, we cannot do infinity. It's exhausted. We don't feel, never we feel it because it's infinity. So what is the idea? We have two cases. Case base, it's a technical name it's called. Que is you try the statement 1, statement 2, statement 3. Suppose you try a statement 1, statement. What is a statement 1 when the n is 1? And suppose it's true. Nice. There are another example in which when you try a statement 1, it's not true, it's false. False is, for example, you get 1 equal 3. It's completely false. It's contradictions, it's false. But you try for n equal 2. And see, n equal 2 is true. This is our base case. So you try 1, fail. 2, fail. 3, true. And after the 3, 4, 5, 6, 7 is true. And this is the base case. Okay? Not necessarily 1. And the majority of the problem I will bring in our subject, x1 and 2. But it's okay. Now, we have the most important moment. We have the inductive step or base or case, sorry. Some book call it different name. Case. What is the idea about inductive case? Cuando yo asumo que eso K es true. Now who is K, professor? Well, K is totally arbitrary. Suppose we have the sequence 1, 2, 3, bam, 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 to M. But you take in the middle one hypothetical I want to call K. You suppose that this is true. Okay. However, if you under this assumption, you prove que A sub K is true, A sub K imply que A sub K plus 1 is true. So under this assumption, you want to prove it. Maybe you don't understand very well now, but you see magically and do algebraically, okay, this is true. Entonces, what situation happened? Well, entonces now happen this and this together imply que A sub K plus 1 is true. And this propagate forever because suppose que S1 imply que suppose que X1 is true. And you prove somehow that X1 implies that X2 is also true. Not X2 alone, you know, X1 implies so the connection, the link to connect the X1 and 2. So now X2 is true. And so now CX2 is true. And you prove hypothetical for any K, X2 implies X3. It's also true because I proved generical for any K. So X3 is true. And this propagate guy, like, do you see the piece of domino? The game is you put different pieces of domino and you push one and fail and touch this and propagate like that forever without do infinity case. This is the idea behind. Do you understand or no? At least the theoretical part. Yes or no?
Yes, Professor.
Yes. Let's come back. Let's come back to the original hypothetical motivation example we started at the beginning. That one. And we try to apply in this example this method. Okay. Entonces, what is my equation that I need to prove? Prove somehow, professor, que 1 plus 3 plus 5 plus that plus 2n minus 1, que es the collection of the odd number, is equal to n squared. This is our problem. Prove that. Okay, no problem. I try to do my best. Mathematical induction. Base step or base case is stem 1. Stem 1 and the left hand side is 1. It's the first one. Stem 1 and the right hand side is 1 squared. 1 squared is equal to 1. This is true. You consider x1 like a base step. Okay. Now, what's the next? The inductive case, que es S sub k. You assume que 1 plus 3 plus 5 plus plus 2k minus 1 is equal to k squared. You assume que this statement is true. This is my supposition. Okay, so it's easy. You only replace m in the original way equation that you want to prove for k. It's the same. Right? However, I want to investigate what happens with the a sub k plus 1. It's the next. Important the organization, guys. This is 1. This is 3. Bring down. This is 5 plus 2 plus. This is 2k minus 1. Cool. But you include 1 extra. It would be 2k plus 1 minus 1. Okay, this is k plus 1, 1 more. And the right hand side, again, 1 more. It's k plus 1 squared. Do you follow me? Do you follow me? We don't finish. This is the most important moment now. Okay, we continue with the xk plus 1. This is 1, this is 3, this is 5, this is 2k minus 1, but I want to do one small transformation here. You apply distributive property. This is, let me try 2k plus 2, no? Minus 1. This is 2k plus 1, no? 2 minus 1 is 1. So this guy is actually 2k plus 1 equal k plus 1 squared. Okay, but remember the most important. Remember the assumption. We suppose that this is true. Therefore, if this is true, we can replace this part for k squared. K squared plus 2k plus 1 should be k plus 1 squared. And now to verify that this is equivalent algebraically, if you want to expand using square root first plus twice multiplication both, it's just FOIL, we FOIL plus 1. Bang! And this expression and this expression is the same. I prove that by mathematical induction. Do you understand the idea or no? Confusing?
Just a little.
What part is confused? I repeat again, or repeat it in best way. What part is confused? The algebra is clear. Do you understand very well that multiplication k plus 1 times itself FOIL is k squared plus k plus another k plus 1 or is k squared plus 2k combined like term plus 1. Yeah, I get this answer, manipulation, the right hand side using algebra. However, I get the same answer, manipulate the left hand side using another algebra. We get the same. It's identity. It's clear. We need to see another example. Yes or no?
Yes, can you do another example?
Another example. Okay, mathematical induction, second example. This second example is more interesting. I want to prove this formula that we are using frequently in the summation notation. Look. Okay, I present to you, you accept. No, professor, okay, I understand. Suppose 1 plus 2 plus 3 plus 4 plus 5, so the first natural number ending in n, pam, 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 plus n is equal n plus 1 divided by 2. Do you remember that formula or no?
Yes.
Okay, that formula is, look, summation from k equal 1, que is the first guy, is to m, que is the last guy, look at that, of the k is equal n times n plus 1 divided by 2. So this is the same idea, but using summation notation. But I would like, in the mathematical induction, no condensing in summation notation. No. You expand like that. Pam. Okay, let's do it. Remember, we have two steps of two cases. The basic. I don't know si it's in 1 or in 2 or in 3 or in 4. The first guy can give me true. Suppose it's statement 1. You take 1 and the left hand side, and you plug in n equal 1 and the right hand side is 1 plus 1 divided by 2. I need to prove que es equal. Si it's not equal, it's 4. Si it's equal, it's true. 1 plus 1 is 2, and 2 divided by 2 is 1, and 1 times 1 is 1. It's true. Do you see? And you take advantage, the first guy gets true. Si it's not true in 1, you try in 2. Si it's not true in 2, you try in 3. But si it's not true in any, entonces this answer is incorrect. But si you want to prove, you try to get the first statement is true. I suppose que from this to the infinity, that is true. Entonces the inductive case is suppose SUK. Now, SUK is easy. You copy exactly the same 1 plus 2 plus 3 plus 4 plus 5 plus k. And the right hand side we have k plus 1 divided by 2. And you guys, you assume that this is true. Okay, I need to respect this assumption. But this assumption allows me to investigate what happened in sub k plus 1. Because if I see the connection between these, I can extend it for all of the natural number. Let me try. I copy 1 plus 2 plus 3 plus 4 plus 5 plus only 3 periods, no 4. This is k, and you include 1 extra, que es k plus 1. Okay, the next, obvious. I need to prove somehow, I claim that, I'm not sure if it's true, question mark. K plus 1, so you replace in the right hand side k for k plus 1. This is k plus 2, no? Because k plus 1 plus 1, it's obvious que es k plus 2 divided by 2. In this case, I do automatically because it's elementary. Okay, let me try. But remember, Remember que you suppose que that part is equal k parenthesis k plus 1 divided by 2. Plus, don't forget this k plus 1. Okay. So let me try to continue doing the manipulation algebraically of the left-hand side. I don't know, sometimes I need to manipulate left and right in order to get the equal sign, the equal expression. Sometimes no. Again, in this case, you write that using common denominator. LCD is obvious que es 2, and we have k plus 1 plus 2 times k plus 1. Okay? And they say keep going, exactly the same. Now you see what? K plus 1 is a common factor. I factor out. This and this is the same. Put like only one out, factor out, and stay in the next second parenthesis. K is K, and this is 2 divided by 2. Wow, amazing. And this expression is exactly the same of this. Proof. You see that?
Yes, Professor.
Let's do one more or enough that part. Because at the beginning, I understand that for the student it's weird that this situation happens. But it's a fact. It's a mathematical method, strong mathematical method. One more. After, see, we have time, start the last section. I promise it's the last. One more. Example 3 of the mathematical induction. By the way, the word induction, guys, is, let me try to explain the idea behind this. Induction is the thing that are doing the detective. So the detective of the FBI want to investigate a crime, and there are different clues, different thinking. So I'm condensing to integrate one idea, no? Is guilty or not guilty. However, is induction is the method for the conclusion of different particular example. You form a conclusion. It's completely backward. It's go to the particular to general, not to the general to the particular. It's completely. It's the deduction is general to particular. Induction is particular to general. Okay. Proof. Example 3. Using mathematical induction. Proof que 1 plus 4 plus 4 squared plus I suppose que 4 cubic plus 4k minus 1 is equal 4k minus 1 divided by 3. Remember, basic case. In the majority, I promise, I guarantee in my class, S1 is the first, no S2, no S3. You take in the left-hand side, the first element is 1, and in the right-hand side, you plug it in K for 1. In this case, I'm using K. No. Much better M. Much better M. Sorry, I suppose I put M. K is the intermediate one. M. Okay, and you replace M for 1. Entonces, 4 minus 1 divided by 3. 4 minus 1 is 3. 3 divided by 3 is 1. And 1 is equal to 1 is true. So far, everyone follow me? Do you understand the idea?
Yes, Professor.
Okay. Now it's okay. It's okay. It's easy. You copy exactly the same, but you consider que no M, sino K. Wow, wow. -1, pero no expone, sino out. -1 parámetro. And you suppose que es true. Si this imply que x sub k plus 1 is true also, entonces I am happy. Let me try. Es 1 plus 4 squared plus plus 4k minus 1. Just bring down that part, but include one extra que es k plus 1. Entonces 4 k, ¿no? I suppose que es k because 4 to the k minus 1, si you replace k for k plus 1, it's obvious that we have 4k plus 1 minus 1 is 4k. Cool. Equal 4 to the k plus 1 minus 1 divided by 2. Okay, pero you suppose that this is true. So that part is identical to this. Therefore, what? There are no reason to have like a 2 expanding. No. I copy like that. 4k minus 1 over 3 plus 4k equal that part. I don't want to copy again because I want to spend time now somehow manipulation this. Okay, you find maybe least common denominator 3, and we have 4k minus 1 plus 3 times 4k. Okay, now you see the 4k now here is common factor. You factor out. So we have, you factor out 4k, you have 1. In between this and this. Temporarily you forgot this. This one I copy after. So 3, this 3, and this is 1 plus 1 minus 1 divided by 3. Do you follow me? So this 4 raised to the k power, this is exponential, I factor out. Put outside. Okay, this. Shoot. And stay here 1, que es this one, and this is 3. And 4 plus 1 is, 3 plus 1 is 4. So we continue the manipulation. Maybe the manipulation is too long, but it's algebra. Entonces 4k times 4, what comes from this 4? 3 plus 1. I finished almost. Now you put together 4k plus 1, because the exponent here is 1, and multiplication is addition exponent, you know. Now we compare this answer with the answer we have here. You see it's the same? Now you prove. By mathematical induction. Cool? And then you see one question like that. Only one. And easy, similar to this. No big deal, no complicated. We have time to present the last topic, que is about I want to erase the board, right? Yeah. Yes or no? Yeah. Yes. Okay. What is the last topic, guys? The binomial theorem. It's easy. Okay. Newton, he was a genius, proved the binomial theorem when he had 22 years old. And what is the idea? It's a formula, for example, to prove a plus b to the n power. Formula, Newton formula. Okay, it's the formula I want to present, pero little by little. Newton formula. Entonces, for example, a plus 1, a plus b to the 0 power, and 1. Let me copy this one here, because I want to investigate the partner of this. A plus 1 to the 1 power, is a plus 1. A plus b, sorry. Because it's the same, no? I want to copy this coefficient and this coefficient here. 1, 1. A plus b is square. When you expand that, it's a square first plus twice multiplication both plus b squared. I want to copy this coefficient. 1, 2, and 1. 1, 2, and 1. That was for n0. That was for n1. That was for the n2. Now suppose a plus b to the cubic power. This is more complicated and long. In order to save time, I put the answer that you believe I'm doing well. Is a cubic plus 3 times a square b plus 3 times ab squared plus b cubic. And the coefficient is 4, 1, 3, 3, and 1. This is for n equal to. And this triangle that I want to form here, you copy only that coefficient. Look, this one is this one. This 3 is this 3. This 3 is this 3. And this one is this one. It's invisible. Suppose, let's continue. Newton said, what happened with the a plus b to the 4 power? It's a4 plus, plus, the coefficients are 4, a cubic b plus 6, a squared b squared plus 4 again, a cubic b plus b 4 power. The coefficients are 1, 4, 6, 4, 1, and this is for n equal 4. Wow! And look at the pattern that Newton discovered. How do you get that number? How do you get that number? That number was addition, 1 plus 3. How do you get that number? 3 plus 3. How do you get the number? 1 plus 3. And this is exactly the same in any position. This 3 is 1 plus 2. This 3 is 1 plus 2. This 2 is 1 plus 1. And this guy is called Pascal triangle. Because what discovered was Pascal before Newton. But Newton using the formula. Okay? Let me continue one more, or at least 2 more. Suppose a plus b to the 5th power is a to the 5th. Okay, let me continue here. This triangle is 1, 5, 10, 10, 5, 1. This is for n equal 5. Remember, when you get this 5, is 1 plus 4. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5. So is 5, a4b, and you see how behave exponent. The exponent start in the same power of the original, a5, no b. Now, the coefficient I discovered was the mathematical law and this Pascal triangle. But the exponent you see, look, is, let me make it soon, F4 and 1. The exponent of A is 4, the exponent for B is 1, it's invisible. And 4 plus 1 is 5, always. But, in the next guy, get 10, is A cubic, B second. Okay, the exponent of A is now decreasing. 4, 3, 2, 1, 0. You see here, 3, 4, 3, 2, 1. No, this is a mistake. 3 is B. Look, this 3 is in the B. Let me, rectification. B0, 1, 2, 3, and 4. B4. What are the next? The next 10 again. A to the second, B to the third, 2 plus 3 is 5. Do you see how the exponent of A decreasing? However, the exponent of the B increasing from 0 to 5 in that case. Plus 5, A, B4, plus 1, que es B5. You get the idea or no? Or we need to see one more? You get the idea, guys?
One more.
I suppose que no, no? Let me try to write, to finish this. The formula of the Newton. And we practice this formula next time. O sea, first of all, Newton discovered que A plus B raised to the n power, the n is 0, 1, 2, 3, 4, 5, 6, 7, 20, 200, whatever. Es a summation. Es a summation. It's a formula. Newton write using summation notation. And we have, when we start in K0 and ending in M. So in total, look at that. Important. So you raise to the fifth power, 5, you have 6 terms. 1, 2, 3, 4, 5, and 6. We have one more. The reason is clear. Because in between 0 and 5, we have 6 terms. In general, between 0, que es the first, 0 is the first. To the end, we have n plus 1 term. So this summation always, suppose 1, we have 2. Suppose 2, we have 3. Suppose 3, we have 4, and so on. And we have one coefficient. Okay, I have no idea what is the formula for this. But I discovered que obey the Pascal triangle. Okay. And we have A, que is the first one, raised to the n minus k. And A, m is, for example, in this case is 5, but k is k0, k1, k2, k3, k4, and k5. So k is the index variable of this summation, que start in 0 and ending in 5. Okay, because n is 5. And b sub k. So this represents the combination of the multiplication A and B with the corresponding exponent. One exponent is decreasing. The exponent of the first, que es A, is decreasing, but the exponent of the B is increasing. Okay? Entonces the challenge is, there are formula for this? Yes. Pascal triangle is using when exponent is small, 5, 4, 6, 10 maybe, but increasing dramatically. Therefore, Newton discovered the formula for this. It's the same formula that we are using in probability, in statistics of the combination. Combination and element taking K and K. Suppose you have, I don't know, 5 elements taken by couple 2 by 2. So it's the combination 5 and 2. So, but with the formula is n factorial divided by k factorial n minus k factorial. Let me recall who is the factorial, guys. Factorial is, suppose I want to find Why not? This element. This element is combinatory 4,012. Okay, because this is n equal 4, but it's located in the position 2, no? It's 0, 1, 2. Entonces es 4 factorial divided by 2 factorial, 4 minus 2 factorial. What is factorial, guys? What is factorial? Factorial is 4 factorial. Is multiplication 4 times 3 times 2 times 1. Likewise, 5 factorial is 5 times 4 times 3 times 2 times 1. So in general, n factorial is n times n minus 1 times n minus 2, bam, 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 to 1, ending in 1. And we come back to the specific example. 4 factorial, we can expand. Well, no. First of all, you use 4 factorial divided by 2 factorial, and 4 minus 2 is again 2 factorial. But 4 factorial is 4 times 3 times 2 factorial. Pero es que 2 factorial es 2. 2 factorial es 2 times 1. And 2 times 1 is 2. So basically, this is 2 and this is 2. This 2 and this 2 is cancelled. And this 2 is cancelled with this, is 2 times 3 is 6. And you get exactly the same, this 6 in the position. So what is the Newton formula? And we finish today this class. Look at the formula. After we see application. You erase that part and you copy combinatory. There are many ways to go. Combinatory NK. Another possibility to write this is using this parenthesis NK. Says this is a more elegant way. Okay? Present the book. NK combinatory number. N element taken at K. And this is a Newton formula. Guys, we need to know that to take calculus 1. Okay? Binomial theorem. Okay? Super. We finish. So remember, Wednesday, we start review. Review is short, no long. See, we don't finish, we continue Monday, next month. And that's it. Professor, are the both attachment? Yeah. And the both, Sandra, the both attachment that I sent today was test 5 and final. And both are due next Monday. Next Monday is 25th, no? 25th. April 25th. Right?
Tuesday.
Tuesday. Sorry, Tuesday. Yeah. So basically, I repeat again. Today was lecture 17. We have another 18 start review. Where we end in the last part and the review. We continue 24 review Monday, and 25th and do everything. So we have no lecture 26, and that's it. 25th, 26th, I grade everything. Guys, important, 3 important. Please verify in Canvas your grade. Any problem? Remember, I am human. See, I make a mistake. You communicate with me and explain me, Professor, no, you put 100, you put 20, I have 100, okay? To say, I verify, see you are right, I change that, okay? Just want to reconfirm it, yeah. Sandra.
Okay.
Guys, do you follow me? Everyone, at least 1, 2, 3, 4, 5, 6, 7, 12 students gets present today, pass the class, right?
Sí.
Okay. So clear? Everything is clear? See
Yes,
you next
yes.
time. See you
Yes.
Wednesday. Here. Bye-bye.
Bye-bye.
Anytime.